Hey everyone, welcome back to another brand new video. So, every AI we use today is a genius with severe amnesia. It can write a flawless poem or solve a complex coding problem, but ask it what you talked about after a very long conversation, and it has no idea. This context limit, this tiny, fragile short-term memory, is the biggest barrier holding AI back. But a groundbreaking new paper from DeepSeek AI doesn't just offer an improvement. It presents a radical new blueprint for how AI can remember. DeepSeek just presented us a whole new approach on how AI can get an infinite memory, just like us humans. Think about a memory from your childhood. You probably don't remember every single word that was said, or the exact pattern on the wallpaper. You remember the feeling, the important faces, the key moments. Human memory is a masterpiece of compression. It knows what to keep sharp and what to let fade. Now think about AI. Every AI you've ever used has a fundamentally broken memory. It has perfect photographic recall, but only for the last 5 minutes. Once a conversation gets too long, it starts to forget the beginning. It's a genius with severe amnesia. This context limit is the single biggest wall holding AI back from true intelligence. But what if, to solve it, we stopped trying to make AI memory perfect, and instead made it more human? Well, that's what DeepSeek is telling us with this paper. And it looks like the age of the forgetful AI might be coming to an end. Today we're diving into the new paper that DeepSeek has just released, which is the DeepSeek OCR. We'll look at the new technology, the mind-blowing results, and then I will tell you how this could finally be the key to AI with a vast, human-like memory. So, what's the big idea in this paper? Well, this paper basically revolves around a concept called context's optical compression, which is the concept of using images to compress text. See, the problem with text is that it's computationally expensive. The more words you feed an AI, the cost and time gets out of control. DeepSeek's solution is simple but profound. Instead of feeding the AI the text, you feed it a picture of the text. Yup. Now, you might be wondering, how does feeding images to the model solves the problem? Well, this is where the new DeepSeek OCR architecture comes in. The DeepSeek OCR model uses a powerful an encoder, to look at that picture and create a super condensed summary using far fewer vision tokens than the original text tokens. It's the ultimate compression method. And then the DeepSeek OCR architecture uses a decoder, which can basically reconstruct the original text almost perfectly from the super condensed summary. So, in this way, by just feeding a picture and then compressing it and then using a decoder to reconstruct the original text, we can actually decrease the amount of tokens for saving the same information if we use just texts. And the paper shows us exactly how they do it. This is their new DeepSeek OCR architecture. DeepSeek OCR consists of a deep encoder and a DeepSeek 3BMOE decoder. You can think of deep encoder as an eye. The eye, or deep encoder, is a two-stage process. First, a perception model, like a detail-obsessed artist, scans the image to understand the precise layout of every letter and shape. Then, and this is the secret sauce, that detailed map is fed through a 16-by compressor, aggressively shrinking the information. Finally, a knowledge model, like a worldly librarian, helps make sense of these compressed patterns. This tiny, efficient package of vision tokens is then sent to the brain, a mixture of experts decoder. Think of it as a specialist office. It only activates the few experts needed for the task, making it incredibly fast and efficient at turning the visual summary back into perfect text. Okay, so that's the theory. But the paper delivers the proof too. First, look at this compression test. The paper shows that at a 10 times compression ratio, the model can reconstruct the original text with an incredible 97% accuracy. This proves the core concept is not just possible, but highly effective. But this next chart is the real showstopper. It plots performance against cost. Maximum performance for minimum cost. As you can see, the DeepSeek OCR models are in a class of their own. They achieve world-class results while using a fraction of the computational power of other leading models. The paper proves this method is not just accurate, it's the most efficient system of its kind. Now you might be thinking, okay, it's a super efficient OCR that reads documents. But how does it solve the memory problem of AI? How can this achieve infinite memory? Well, the authors themselves show us the way. The paper just demonstrated that you can aggressively compress visual information and still retain the core content. This opens the door to a new way of storing memories. Think of it like this. Today's information is stored as a high-resolution, uncompressed image. The AI has perfect recall. Last week's information is compressed 10 times, just like in their test. It takes up far less memory space, but can be recalled with 97% accuracy. Last year's information is compressed 20 times or more. It becomes a blurry summary. The AI can't recall every detail, but it remembers the main topics, the key takeaways. This is exactly what Figure 13 in the paper illustrates, a system where memories gracefully fade instead of hitting a hard wall. And this is the whole solution to the amnesia problem that we got through this DeepSeek OCR paper. An AI with a theoretically infinite memory, where the cost of storing that memory is managed by this intelligent, human-like process of compression and forgetting. This makes the memory of the AI just like humans. Instead of forgetting everything at once after they reach the context limit, the AI will gradually forget things just like a human. DeepSeek OCR is one of those rare papers that's both a practical engineering marvel and a profound conceptual breakthrough. It delivers a tool that solves a real-world problem today, efficient document processing. But more importantly, it provides the technical proof for a future where AIs are no longer geniuses with amnesia. It gives us a blueprint for building AIs that can learn, remember, and grow with us over a lifetime. The age of the forgetful AI might be coming to an end. What do you think this technology will unlock? Let me know in the comments. If you enjoyed this deep dive, don't forget to like and subscribe for more breakdowns of various AI tools that are shaping our future. Thanks for watching.